Constants. We're going to be talking about constants. But first, let's see what the notes say. Constants. A constant, as used in mathematics and sciences, can be described in any of the following ways. First, a number or value that does not change with time or situation. Next, a number with a fixed value. Next, an outcome whose value remains the same in any circumstances or situation. Characteristics. First, all real numbers are constants. Constants also play other roles, such as coefficients, parameters, constants in algebraic expressions, equations, functions, and polynomials. Constants, in addition, play important roles in mathematical, scientific, and engineering experiments, as well as appearing in various relevant formulas. Constants. Like we said in the note, you can see the description in the video notes. That's a number or value that does not change with time or situation. A number with a fixed value, or an outcome that remains the same in every situation or circumstance. So, now let's take a look at the characteristics. First of all, is that all real numbers from negative infinity to positive infinity are constants, including decimals, fractions, rational numbers. Of course, rational numbers will mean fractions. They are all constants because each one of them has its own value. It doesn't change with time or with situation. Now, in addition to those being constants, constants also serve some other purposes in maths. Let's take, for example, they serve as coefficients in mathematical or algebraic expressions. Example, you have an algebraic expression, ax plus by plus c, just an expression. Now, x is a variable, and of course, independent variable. Y is a variable, the dependent variable. Then, a, b, and c are numbers, and on their own, they are constants. But here, a serves as a coefficient of x. B serves as a coefficient of y. Okay? Well, you can say C also serves as either a coefficient of x or y, but that y or x is raised to the power of 0. Therefore, it is 1. So that's why we don't worry about it. Now, what is the job of this coefficient here? The job here is to scale up or down the value of the variable. In other words, if the variable is assigned with a number or a value, this number will scale it up or down. Assuming this number is on the positive side, it will make this term go higher. If it's on the negative sign, it brings it down, and so on and so forth. So They serve as coefficients. Okay. Then also they serve as parameters, especially when it comes to an equation. Example, look at this equation here, which is the standard form of a linear equation. Ax plus by plus c is equal to 0. Now, here, an action is required. What action is that? The equality sign makes it, creates an action. In other words, we have to find the values of x and y that we make this side of the equation equal to 0. Now, what is the role played by A or B or C in this equation? In addition to being coefficients, they serve to influence the outcome of this interaction. Example, Ax, of course, scales up the value of x, By scales up the value of y. But now, when you put this in a graph, when you try to introduce this in a form of graph, this will affect the shape of the graph. Of course, if you want to do the graph, you may have to rearrange this this equation, so that you can separate the dependent variable and the independent variable. And when you do the graph, what happens? It changes the shape, the position of the graph. So these parameters, that's A, B, and C, change the shape and position of the graph. We'll come to that when we do linear equations. Then the next thing is they serve as constants. Constants also appear in formulas. Now, let's take an example of a formula. This formula represents the area of a circle. Area of a circle is equal to pi r squared. Pi is a constant, and this pi is the value of the circumference of, the value of the ratio of the circumference of any circle to its diameter, no matter the circle, no matter the size, no matter the location, no matter the situation. The ratio of the circumference of a circle to its diameter is always constant, which is represented with the Greek symbol pi. That's why we said outcome will remain the same in any situation or circumstances. So you can see where constants appear. However, it's not a big deal. We're going to be coming across constants in the lessons. So just for you to have an idea of what a constant is. Also, as always, I recommend check your textbooks. Check your textbooks and maybe any other source of information to reinforce your learning. I see you in the next video.